Welcome to another episode of Deep Dive Fridays. Today we are talking about aerobraking. Today we have a guest.
Thanks, Mikko. Hey, everybody. My name is Benno. I'm also known as Jettison Guy on Twitter. It's good to be here. I'm just another space enthusiast, like the rest of us watching this all play out at the moment. You know, the whole Starship program and everything. And I've been sort of in the background there, helping out some YouTube channels like What About It and Marcus House. Met a lot of people along the way, and it'd be great to sit with you guys and talk some stuff about Starship for all your listeners out there. So thanks so much for having me.
And I'm AnotherSpaceNut, a regular voice on Total Space. Thanks for tuning in today, guys. Let's get stuck into today's deep dive.
Awesome.
Aerobraking, Benno, tell us more.
Aerobraking. Well, after I watched the Mars Society's convention videos, I've caught up on a few of those. Something happened after that where I got curious about the end of the flight, like getting to Mars and what's going on there and what crafts we've sent. And ultimately, I was sort of asking the question, what's going to happen when the ship does arrive? I put it to you gentlemen sort of thing about an interesting subject. Here we are. I kind of got curious to what happens on approach, or you've got, just different stages of flight and the different craft we sent there. I got curious about the weight because the Starship's probably the biggest thing we're ever going to throw at Mars or ever have. Maybe it'll get bigger in time for sure, but right now it's just going to be the biggest thing coming at that planet we've ever sent. Getting it off the orbital launch pad or off at Boca Chica now, it's just like a mind boggle. And seeing that thing fly, we're yet to do it, but we're so close. And it's like, well, every time we have one of these little steps towards progress, there's a new question in town. I've just sort of decided why not skip ahead a little bit, sort of see what it brings up, what questions it can raise.
It does raise a lot of questions, really. I'm glad that you brought this one forward. There's a lot of people focusing on what's going on in Boca Chica right now, what the 15-kilometre hop looks like, what Flight 1 looks like, what kind of payloads they're going to be. Nobody's actually asking these kind of questions about the end game of the Starship program, are they?
Yeah, it's because it's so unseen. Like, we've got so much. We've got the Deep Space Network and, like, flight controllers and all those guys, like, monitoring the craft through its cruise phase. I mean, Perseverance rover is on its way now. All those guys, all those minds behind that to make sure that thing lands properly is a big deal.
Yeah.
And when I see that just cruising, it's huge. Yeah, Mikko, what do you think?
Yeah, it's a big deal. And if we take a look at previous Mars missions, there's a lot of them have failed. I think it's over 50% that haven't made it to the ground in one piece.
It was kind of like, hearing on one of maybe your first episodes where Ryan speaks about, all the craft lying about on Mars that have failed, where they are. There's just lying there. Who knows what's coming out of them and stuff like that with chemicals and God knows what. Seeing any craft fail is just heartbreaking. The amount of work that goes into that. And to see, hear or, read about these failures, it just must really hurt.
I was just looking, based on Mikko saying that over 50%, the number is 2/3. 2/3 of everything we've sent towards Mars has failed. If that's, rocket failure or instrument failure, there's several ways they can fail, but it's been 2/3 overall that failed.
I read something like 19 successes and 28 fails. So we've got quite a few craft we've sent. The Russians gave it a crack back in the 60s. NASA came sort of out on top with a few more successes. And then the Vikings are the biggest of probably what we've said there. When you do arrive, what kind of things do we have to face there that it's like, it should be all right to just meet up with the planet and do what we're going to do. But there's so many ways to do that, and we haven't seen this kind of mission. In February, we're going to get to see the latest Mars landing.
Yeah, and there's the Chinese lander and also the NASA's Perseverance.
There's some crazy missions I was sort of looking at when there was a lot of failures and into sort of why. And they were talking about how they were stretching a lot of the budgets thin on a lot more missions and sort of looking at it as a cheaper, more expanded approach to space investigations and space missions, etc. it was interesting to see how they changed the paradigm there with the early rovers and stuff like that, and took on a whole new approach. I think it was the CEO at the time, and he was talking about how they decided to put a lot more resources into singular missions to Mars, which is probably why we've seen a lot more success. So I think by the time Elon's got that Starship flying, no problem, landing, no problem, atmospheric, all that, there's all these deductions he's going to have to make, calculations make to simulate the other end of the stick in the sense of the mission. I'm looking at the sequence of events. I'm looking at the Doppler plot, which is something I've never really sort of heard of before, but that's how they measure the distance and velocity and stuff like that when they've got to do critical engine firing and stuff like that.
Well, that's interesting.
Yeah, they got the trajectories they got to pick out. They've got to probably get back some communications where they're always aligning the craft's antenna to be at Earth to give them the latest stuff, latest readings. And, it just goes on. This list is huge in the sense of cruise mode to landing. There's so many calculations. I'm sure these guys are going to be crunching the numbers or already have. It's like, where do you want to land? It's like, well, let's pick that well in advance. Yeah. Because you've got to have something to aim for. And I guess, there's all these orbital mechanics that come into play, which I could go on about. But, the bottom line is it's how heavy is the ship? How fast is it coming in? Where's Mars going to be at when it finishes up its cruise mode and starts for its orbital insertion? And hearing Elon talk about what kind of approaches he might take to the best landing site was exciting. I was listening to that a few times. I was just like, it's a good question too, to give him the opportunity. So what about you guys? Have you got sort of landing sites in mind?
I mean, I know that I definitely want to climb Olympus Mons when I get there, if I get there. So anywhere around Olympus Mons would be good for me.
So that'd be like walking from London to the edge of France?
Yeah, I mean, it's definitely going to be a different kind of challenge, isn't it?
It's a big volcano.
Absolutely anywhere on Mars, so long as I'm touching the surface, I don't mind.
Yeah. What about you, Mikko? Have you got any ideas there?
I think the landing would probably happen somewhere in Arcadia, Planitia. I mean, that's part of the lowest parts on Mars, so there would be a bit more atmosphere to slow the vehicle down before landing.
Yeah, that's interesting.
SpaceX did nominate several sites at Arcadia Planitia, didn't they, as their potential landing sites as well. And I know NASA have shown quite a keen interest due to the potential discovery of water ice under the surface there.
That's the criteria I was talking about. He said it's got to be ice, there's got to be a place to put the refueling stuff and get all that going on, probably equatorial for temperature, and a place where the sun can come up and charge solar farms and stuff.
Yeah, and it's quite interesting to see that when SpaceX asked NASA if they could look for possible landing sites, and they did look at them. So SpaceX has gotten some knowledge from NASA.
I mean, it's like, could you please send 50 at once so we can go everywhere?
I think they actually listed almost 10 places where they could land.
Oh, there's so many cool spots. I can't imagine what takes priority in that.
Yeah, I think the requirements are there's water ice, thicker atmosphere, and fairly warm temperatures.
Yeah. So it's like, well, let's see what's happening 6 months before the next launch window, which is what, 2022.
Yeah, 2022. SpaceX could probably send some cargo ships then already.
Yeah, it was the math that he was talking about was just crazy. But, that's where I sort of thought about, what we're looking at right now is the atmospheric re-entry, the belly flop maneuver or the skydive or whatever you want to call it with the Starship test. And I was thinking, if they get that down, which they will, and we might see some mishaps on but I was thinking, how do you simulate that for Mars when you've got such a different densities and atmosphere and stuff like that? I mean, it's probably for the true orbital mechanical guys out there. I thought, it'd be a good one to sort of bring to the audience at Total Space. So when they finally get this Starship re-entry thing going on, or they do the orbital re-entries and base their data off that, and it's like, well, I guess you got to have the rocket come back from the moon to simulate a hotter re-entry to maybe get the maximum effect for back to Earth. But I mean, I'm just wondering, will he bother? Will he just keep building them and just sending them? because you don't need to re-enter anything.
Yeah.
He's making them cheap enough in comparison to other launch providers. You know, like some of the numbers that are floating out on the internet regarding how much it will actually cost to send payloads. You know, like it's money over fist for SpaceX. They can just continue to pump these out and throw them at Mars until they get it right.
You know, and plus there's all these other missions that are probably coming about in the next launch window, but we don't even know about yet.
Yeah. One mission we know is the European lander.
ExoMars?
Yeah, ExoMars.
ExoMars, yeah, because they postponed that one, didn't they?
Yeah, parachute problems.
They must have switched over to Xylon.
Maybe.
Regarding the braking to get there, as the episode title suggests, do you think it was a bad move for SpaceX to kill the Red Dragon program?
I thought it was really unfortunate that that happened during one of the tests, because it did create more sort of constringent conditions for SpaceX to work within for the design of the capsule for manned spaceflight.
It would have been really cool to see the Dragon land with propulsion.
Yeah, I mean, it would be like a rover. I mean, the Perseverance lander's got that whole bungee system and stuff with its little thrusters. I mean, I don't see the difference really, but if you've got men in the capsule, you have to know. I mean, that test, it's a God-given miracle that we had that happen. Any dude got in it. You know, any astronaut did get in that. It's like, we don't have time to figure out so much as how to redesign this to make it work. We have to start with something that has less parts. Like as Elon says, best part is no.
It's interesting to think about that. Correct me if I'm wrong, but I think every lander that has successfully landed on Mars has probably used parachutes as step one.
Yeah, the atmosphere is a tricky thing. I think that's, maybe the Xylon thing is going to change all that for future missions too. Maybe it just needs to be, that's the thing. We just haven't got boots on the ground to know or measure that atmosphere on a real-time rate. I mean, there probably is some weather channels out there for all you listeners. If you can find that, send it in, please. I might have a look myself. And I'm really curious to see how the Starship performs in Earth's atmosphere. The new belly dive maneuver, skydive, belly flop, whatever you want to call it. We're all on the edge of our seat.
Yeah, I think the entry on Earth will give us a quite good look how it's going to look on Mars, because it's pretty much similar, but of course on Earth the atmosphere takes most of the speed out and we don't have to use that much propulsion.
So, I mean, it's just got to come in with a bit of grace, you could say.
What is the best way to come into Mars? Because, I mean, future colonists are dependent on this working out, is it okay to get, so if you were a early settler, one of the few scientists that are going to be touching down first, and you'd seen SpaceX get the kind of failure rates that we've got from Mars missions currently, would that inspire confidence?
Yeah. I'm just confident based on what I was saying before about the paradigm of NASA with stretching their budgets thin to make cheaper craft, to make more exploration, which didn't work out. I think the paradigm's changed a lot. That's why we're seeing a real slow progress with a lot of things. But, you've got the most insane rover we've ever seen going on Mars right now. And you can see that they've just really focused on those big single ones instead of heaps of little ones, it seems to me. And I think with all the data they've got, with all the things they've failed on, things we succeeded on, a good shot the math's going to be right.
Yeah. How about when Starship comes to Mars? How do you think the aerobraking process will happen? Do you think it will go once to the atmosphere, or shall it go to the atmosphere a few times to slow the speed down?
Then you've got the Mars orbital insertion burn. So that burn will be going for so many minutes.
Yeah, but it doesn't have to be too long of a burn because it's the Hohmann transfer, so Starship will be going slowest when it's near Mars.
Yeah. Do you think they'll be using more fuel in that initial burn to get there, or more to slow it down?
I mean, if they have the spare fuel, of course they would like to make it as short as possible.
Yeah, because Elon's making out like it's air braking with the fins and raising the belly up by an inclination of around 45 degrees, I think. Is that right?
Yeah, and before that, I think they will do like 3 to 5 or even 10 orbits, just scraping off the atmosphere.
Yeah, I was wondering about that because I know the first swing out for the Mars Global Surveyor was something like 33,000 kilometers. It went straight out past Mars, only to come back in again and go around.
Yeah.
So you've got that whole aerobraking technique where it skims the atmosphere, and it said that it went down as low as 300 kilometers into the atmosphere. So I'm thinking, okay, so if you were to simulate the Earth's atmosphere, it would probably be a lot higher and a lot more dense, of course, and the gravity's a lot more. So the idea is the craft could probably dance a little bit before it drops in, and that leaves the question about the landing animation on the website and whether that's going to be changed.
I think it's the final entry.
Yeah, it's more about that. You know, the aerobraking techniques on these Mars probes compared to the Starship going so fast. I'm wondering if that first hook orbit to go, it would just slingshot sort of past and just wipe a little bit of atmosphere to slow it, you know, a good 40% off that, wipe off about 30% of that first bit of speed without using any rockets at all.
Yeah.
So they can just nick it and just ride the atmosphere that little bit to wash the speed off and come in using minimal fuel. You've got the delta V of the Doppler shift to measure how fast it is going from Earth. You've got the fins. You've got the distance that it'll go down into the atmosphere on that first wipe. The distance it goes past Mars for that first initial contact. So they'll need to make sure that that first pass they can get full contact again, because you have to wait or you have to give it an arc angle. So the idea would be to approach kind of like to cross the face. But if they're going for equatorial landing spot, you know, it's like, what is that? That's another thing that the JPL guys and SpaceX are going to have to work out as well.
Kind of decisions. The landing site determines everything. You know, like if you're going to circle around one of the poles, it's going to be a much shorter journey around Mars than, say, an equator location.
When like when we see the first flight and it cuts the engine and it falls back, when it goes through that upper part and goes through that little window, you know, heating up and all that stuff, and the tiles kick in. Once it goes through and they start steaming and cooling down, it's like, how fast will that thing be going?
Pretty much.
I don't know how many minutes it'll be for Starship.
Probably something similar than with the shuttle.
Yeah.
I mean, aerobraking is rule 1, page 1 of the How to Survive on Mars handbook, isn't it? Because there's a lot of things that can kill you on Mars. There's only one way to do it right. And I think that starts from the get-go at aerobraking. If you take, you know, all the getting to Mars out of it, all the leaving Earth and interplanetary travel, actually, once you arrive in Mars orbit, you know, that key is going to be aerobraking. And if you're not braking fast enough, then you're just not going to survive on Mars. If you do make it and the mechanics are worked out right, then you've still got a massive fight on your hands to survive on Mars.
Yeah.
Yeah, well, I mean, like the good thing about the whole insertion orbit is that a good time to sort of figure out where you're going to land, a good time to establish communications, a good time to orientate where you are if you're a little off course, you know, all those things. But if you're lagging behind because of something and you're like a little bit off and you need a bit of thrust, you better have some in the kitty. The other real sort of thorn in the side is the timing of Solar Max. That's the other thing that just is like, oh man. So I'm just thinking, let's try a few cargo missions and send a lot of cameras on that ship. Let's just see what happens.
Yeah, at the moment it's actually going to be a bad timing because new solar cycle has started, so they could have a bit more radiation than before.
Like he says, you supply the will, I'll supply the way to Robert Zoom. You know, that was cool because there is so many minds working on this stuff. And like, you know, just to sit here and talk with you guys about it, it's a privilege, you know, because there's just so many interesting going on. I mean, the helicopter, the cameras on it for Mars, the Mars Perseverance mission, the lunar missions that have even failed, but NASA picked them up and said, "Oh, your craft's there." You know, there's all this talk about colonizing man stuff and landing ships and everything, but it's like the regolith on lunar surface is an issue. All these planetary things. I'm looking forward to just seeing a nice, clean demonstration without anyone or anything if they can manage it. I just want to see Like we watch a Starlink launch like it's nothing.
Yeah, definitely.
The booster comes back. We're we all, after a year of just solid launching and watching these satellites go up, it's just like, wow, there's like 850 million. And it's like we just watch those launches and just go, yep, that's how you do it. Yep, no problem. And there's a complacency with that. Like, to see that happen 20 years ago, you'd be like, this is a sci-fi novel again.
That 20 years ago you refer to, I think a lot of people that are not necessarily listening to this podcast, the average person that's not interested in space flight still doesn't believe it's going to be a reality. The three of us have discussed at several points how we're the outcast, and it's a commonplace amongst rocket nuts that we seem to be the outcast at the pub, while everyone else is talking about the football or the boxing. We're talking about the SpaceX launch or the Blue Origin suborbital attempts and stuff.
Starship program is sports to the mind.
I agree. I was just going to say, as the Starship program takes off more, we are going to see more and more people come on board with the idea of becoming multiplanetary and going towards the moon and towards Mars, and this great in-orbit adventure that we're heading towards as a species.
We're looking at one little aspect of one company and their approach to it. There's, JAXA, there's ESA. I mean, Japan have got some pretty cool lunar stuff. And you can see the innovation is exponential right now, and they're all searching for a way to make it cheap, reliable, and reusable. And that paradigm's all good and well, but Elon's questioning the amount payload. We need 5 million tons to get 1 million tons to Mars. So we need to get 5 million tons in Leo to get 1 ton to Mars.
Yeah.
And he says, and then he starts talking about how the rockets right now, even reusable, are ridiculous because their payloads don't exceed much over 500 kilos. And he's like, if there was an emergency and we had to pull together right now, they could probably pull off 1,000 kilos for a payload. It's like, wow. And he goes, that's not even 0.1%.
Mm-hmm.
It's not just the initial settlers and their initial belongings you need to worry about. It's about continuing to go back there and doing it in a safe way. And aerobraking does play a key part in that. You can't just dump astronauts and a few vital supplies on Mars and then not worry about them. There's going to be regular refuels. Sorry, not refuels, resupplies. And so you want this consistency really. Like you were saying, it's 5 times the amount of volume we need to get there. And so then it becomes about, okay, if we're sustaining a colony of 1 million people on Mars, like the Grand Division is,
Most definitely. The payload is a massive factor, but, just being able to get a craft that's able to get there and stay there, land there, and send some images back, I mean, that's always a big thrill just on its own. The first Starship's literally a metal stainless steel rocket that's represented as a flag. Why not? It's good. So the next time there's success and maybe some people are on it, say, by 2030, at least they'll have a place to stay.
So to wrap this up, what are your guys' opinion on whether Starship will land on the first try?
AnotherSpaceNut, would you like to go first?
Are we talking the first landing on Mars or the first landing on Earth?
First landing on Mars.
I think it's going to be a critical one to get right. I think if the first Starship fails, it will put a lot of doubt in people's mind. I've known you guys practically, for the entirety of the Starship program, and to see them blow up sometimes is disheartening for us. Now, imagine the world's media and the world's attention on something so big going to Mars and then failing. What kind of negative setback would that have? And so I feel it's quite important for SpaceX to nail that first landing so that we don't set back human space flight for another 60 years.
Yeah, I think if it's going to be a matter of understanding that craft to the maximum before we even go, I can't imagine what we're going to see by SN25, SN30. I think there'll be some of these little incremental changes, and hopefully they get their lunar version lunar lander version done. That'll be pretty exciting. But the big one that I have probably gone over to you guys in the past is the Deep Space Network, and how the tracking all works and how they can pinpoint that landing. The need for GPS on Mars in order to get it down from a 1 kilometre target to a 1 metre target. I think that's the key, personally. Getting a basic Starlink setup on Mars would be ideal first. So hopefully the first cargo mission brings something like that to play.
Yeah, definitely.
I'm going to say, just off the back of what you were saying, I did read an alternative method for triangulation regarding the first few Starships to go. If we haven't got some valid GPS or rudimentary Starlink network, I think the leading plan was to send a few and then figure out whereabouts they are and use those to triangulate next in line Starships down to the surface.
So like triangulate 3 landing sites and get them sort of hopefully within the ballpark to be able to create a pyramid on the or like a triangle on the surface to land a craft right in the middle.
Yeah. So if you were shooting for Arcadia Planitia, you'd send 3 at opposite ends of Arcadia Planitia to each other, and then you'd be able to use those as a relay to be able to guide further Starships down into Arcadia Planitia.
Yeah, that sounds great. That's what I'm talking about. That's what you want. You know, if you go to Mars for the first time and you're the first guy, no one's going to welcome you. Maybe some aliens on a turret gun might. Who knows? But, you know, the fact is, once there's one person there to say, "Oh, that was really scary." I'm Brian Grazer from Mars Mission 8 SpaceX reporting. I lost the crew and all that. Sorry, you're going to have to edit that out. I'm going to have to edit that out, sorry. What you're saying before, sort of like a bad tone from an unsuccessful or a failure, I think Elon's definitely shown us that with the amount it's going to cost him in the end towards like the manufacturing side to make it so much cheaper, I think it's not going to be that big a deal. It'll just be a matter of time wasted more so than on that first one. But I think if you've launched maybe 2 or 3, maybe 4, so you've got a spare and those 3 that you're talking about with the Deep Space Network, or like a mini Starlink grid, I mean, I'm thinking if that's set up or it's not, the chances are quite good because it's got the aerodynamics covered, it's got the RCS thrusters covered, and it's got seriously good ISP coming out of those Raptors. I don't doubt it because everything I'm watching, it's like, well, I've seen enough tests to know that it's working fine so far. You know, we've had some massive failures, but they were all manageable to allow him to go forward with the program.
And expected.
It's not like he's had to go from scratch, you know. I got 80% confidence in the refueling, but that's what I want to see before I go too far on all this. But once that's in place, I'm like, how does this work, you know?
Yeah.
This is exciting. It's like it's the Starship's heading towards Mars. What's it going to do when it gets there, you know? What's the deal? So it's like, so yeah, we're here to talk about the Starship and how it's going to actually stop and land and not crash on Mars so we don't end up all depressed.
Yeah, that would be depressing.
Yeah, I got, when we saw Mark 1 just not work, I was kind of like naive to the fact that it wouldn't.
Yeah.
We all learned lessons since Mark 1.
I didn't know what was going on until Mark 1 said, hey, this isn't how you do it.
I mean, I think we put a lot of love and devotion into watching these Starship prototypes grow.
Oh, it's been great. I mean, I'd love to take this opportunity on the show to really thank, you know, the community, especially Mary and Boca Chica girl. If you're not supporting her, wow, great photos, great updates, just sheer perseverance and passion. Loving every minute of that. The world should be giving her a Nobel Peace Prize or something.
Definitely.
And without her, I wouldn't be speculating probably much about it. You know, it's been great to be able to talk to you guys over the last couple of years and, you know, hang out and talk about this stuff and, you know, really see where it's going and see the little incremental improvements to, you know, get off Earth, go around Earth, fly off to Mars, hit that and make sure it sticks the landing and everyone gets their first pictures and goes, oh.
Yeah.
So no one knew about this program until bang, front page news. Starship lands on Mars.
Yeah, that's probably how it's going to happen.
So to answer your question, Mikko, I mean, I would love to see them stick that landing and have front page news so everybody finally knows about it. And then we can start seeing a heap more people excited about this whole thing.
Yeah.
I mean,
that would be the best
great.
way for it to happen.
Yeah, I mean, what about you, Mikko? Would you be one to say go around the moon on Starship, or have you thought about, the intercontinental side of it? Anything like that?
Well, it's all about the money, which I don't have. But if...
Oh, that's all right. I mean, Total Space will pay for it. Checks in the mail.
Yeah, but I would definitely go around the moon.
Yeah, me too. I think it's like, because we haven't seen something just land over and over with success. We've seen the Apollo missions and we've seen the success with the lunar missions. It helps the mind sort of settle on the idea that it's possible. And, we're a little bit safer at a shorter distance away if something does go wrong while we're learning how to become a spacefaring species. So here's to the community that are supporting everything right now. All you guys out there that listen to this, thank you so much for all your input and all the great support I see around the community, YouTube and the Twitter and everything. It's insane. It's so good. Insane means good in Australia. Thank you, everybody.
So thanks for listening. This has been a Deep Dive Friday. And thanks, Benno, for visiting us.
I appreciate it, guys. It's so good to be here. Thanks so much for having me on the show, and thank you to all you listeners out there. Looking forward to seeing where we all end up with the Starship mission and getting to Mars. Bring that on. Thanks so much, guys. I'll see you all on the next episode.
Thanks.
Thanks for listening to this podcast today, guys. Remember to support us with a subscription and think about becoming a supporter. We do now have Patreon, some special tiers available that are limited. Once again, thank you to our guest today, Benno, at Jettison Guy on Twitter. If anybody's interested in learning more about what Benno's got to say, I would definitely recommend giving him a follow on Twitter.